I'm Ms. Schultz, and this is a video on the product rule for AP Calculus class for Boston Collegiate Charter School. So let's get started on checking our intuition, and I'm about to explain what is the product rule and then why do we need it. But so let's consider this function, y equals x to the 10th times x squared minus 1. So I'm given this function that is a product between two terms. This is the first term, x to the 10th, x squared minus 1 is the second term. So my question is, how do I take the derivative of a product? So the problem is find y prime or find dy dx, either of those notations. So far, we've only ever differentiated polynomials in standard form. So aka, what we've seen so far is a string of sums or differences of single terms. We've also seen, we've taken the derivative of trig functions, but just single terms at a time with some or difference. We haven't seen anything with a product in between. So the first thing I'm going to do is just check our intuition. In order to do this, I want to find the real derivative, okay, so that way we have something to check against. Because this, I can rewrite this in standard form, and I know how to take the derivative of polynomials in standard form. So rewrite this, and this is going to be a big thing for our course, to rewrite things in order to get it in a form which we know how to manipulate. So take a sec, think about how you can rewrite this. Yeah, so you rewrite this by distributing. You want to use the distributive property. So x to the 12th equals x to the 10th. I haven't done anything calculus-wise. I've taken a derivative, I just rewrote it. So now you're going to differentiate this. That means the verb for take the derivative, or derive. Both of those work. So use your power rule, picture what happens with this, etc. Take the derivative. Alright, that is the derivative. Y prime equals 12x to the 11th minus 10x to the 9th. So this is going to be our gold standard. I start with this, and this is my derivative. So I found the derivative, and I don't even know the product rule, but I'm going to use this to test my intuition on the product rule now. So just write on this page the summary. So this is what I start with. This is y, and this is y prime. So my question is, what if I didn't want to write it through distributing? So my question is, if I take each derivative, the derivative of this and the derivative of that, and then I multiply them together, is that y prime? That's my intuition. It's my gut. If I take the derivative of this, take the derivative of that, and multiply them together, All right, so I'm going to take the derivative of x to the 10th and take the derivative of x squared minus 1. So take each of those derivatives. All right, so 10x to the 9th and 2x. Now, multiply them together. Multiply them together, okay? So let's see, is the derivative of a product, here's my guess, the derivative of a product is the product of each of the derivatives. So I have each of the derivatives, I'm taking their product, which you just did. 10 to x to the 9th times 2x is 20x to the 10th. Is that the derivative that we know to be true? Nope, it's not. So in other words, you can't distribute a derivative like you can distribute over multiplication. You can't, when you have a product, you cannot just take the derivative of the first term, the derivative of the second term, and then multiply each of those derivatives together and have that be your answer. You cannot. This is clearly not equivalent to that, not at all. So this is why we need to find a rule for taking the derivative of products, aka the product rule. Because it's not as simple as you would think. We're going to derive it a little bit. Yeah, we're going to derive it. So what is the derivative of a product? So here's my goal. All right, we have our goal. Start with this, end with that. Okay, so I'm going to introduce a little bit of notation. Okay, so I'm going to call the first factor u. So when you have a product, just to review, the first term that is being multiplied is called a factor. Each term is called a factor. So I'm going to call my first term u, and my first factor u, and my second factor v. And then I'll use the notation du, just a simple du to stand for the derivative of u. I could write it du over dx, that would be the long term, but we'll just keep it simple and say du, and then we use dv to mean the derivative of v. Let's do that, okay? So let's make this chart so we keep ourselves organized. All right, got the chart, so my u is my first term, x to the 10th. So write u equals x to the 10th. V is my second term, v equals x squared minus 1. And then du and dv, we've already found those. Du equals 10x to the 9th. dv equals 2x. 2x minus 0, 2x. The derivative constants. All right. So now, here's thinking time, okay? Through multiplication and another operation. Again, operations are like abstract multiplied by, basically. How can you get y prime equals 12x to the 11 minus 10x to the 9? So you're going to explain this, you're going to try your best. But here's what I want you to focus on, not the 12 and the 10, but through multiplication, how can you get an x to the 11? So see how I have an x to the 10, an x to the 9, an x squared, and an x? Through multiplication, how can I get an 11 going on? Okay? And then, how can I get an x to the 9th going on? You know, so think about these terms. This is like, you know, that has no x's. So do your best. So you're going to multiply, and then there's going to be like an abstract multiply and divide involved. So do your best to explain specifically, like, I multiply u times blank, and then I multiply this times this. And then if that's as far as you can get, cool, but maybe you can see, and then I do this. That's how I would achieve 12x to the 11th minus 10x to the 9th. So I'll give you some thinking time. All right, and we're back. So here's where we're at. Okay, I just made it nice and so if you do 10x to the 10th times 2x, we get that 11. Do I get the 12? No, but I get the 11, okay? And then this, I can also get an x to the 11th here. And then if I do 10x to the 9th times 1, I get that x to the 9th. So let's actually just see what that is. So u dv, if I do u times dv, I get 2x to the 11th. If I do v times du, again this, v times du, then I get 10x to the 11th minus 10x to the 9th. With me. And then, now that I have these two written out, how can I get 12x to the 11th minus 10x to the 9th? I add them. Okay, if I sum these two, then I will get my answer. This isn't a formal proof, but this is a good gut check of figuring it out. So addition. Yep, so here's our addition. All right, and then these two combine to get our answer. So here's our rule. uv prime, so this stands for the derivative of u times v, is u dv plus v du. u dv plus v du. Okay, you're going to say it out loud. I'm going to say it, and then you're going to repeat it. Well, also, I'll just say it twice, basically. Okay, the derivative of, so let's say, uv prime is u dv plus v du. uv prime is u dv plus v du. I also, so some people, the chant is helpful. Some people, just the visual organization like this is helpful. They can just visualize the crisscross multiplication and then the sum of those two products. So basically, you're summing two products. The products are crisscross, if you set it up like that. All right, so that's it. That's the product rule. You now know it. Now, this was interesting. So in the last example, have to use the product rule. We just rewrote it through the distributive property. And then we figured out the product rule for fun. But there's tons of problems where you need the product rule. Need. So let's say I just switched it up a little bit and I had x squared times x minus 1 all to the 10. Can you rewrite this through distribution? No. If you said you want to distribute that in, you cannot. Okay? This is multiplication. This is exponents. Exponents definitely come first in order of operations. So you would actually have to multiply x minus 1 out 10 times. Imagine all the little arrows. So you get 2 binomials, you get a trinomial, and you still have 8 more left. I mean, that'd be crazy. Like, there's no way. So this is why we really have a need for the product rule, because for all intents and purposes, you're not going to rewrite this. Like, you will not. Okay, so I just rewrote the product rule here. uv prime equals udv plus vdu. So go ahead, so let's set up our chart, u, v, du, dv. And then you're going to write in what u is, what v is, and then find du, and then find dv. So your u is your first factor, and your v is your second factor. After you get those written, you ignore the original, and just say, okay, if this is u, what's my du? If this is v, what's my dv? All right, so go ahead and write this out. All right, and we're back. So my u is x to the squared, my v is x minus 1 to the 10th. These are my derivatives. This one's a little tricky, but just like when you take the derivative of this, you don't change the x. So basically, like the thing that you're raising the exponent, you don't change. So this, you don't change it. It just stays the same. All right. So now, let's do the product rule together. Yeah. So I'm going to do u dv plus v du. So u dv, x squared times 10, this to the 9th. So I'm thinking, what are my coefficients? X squared is going to be a coefficient, 10 is going to be a coefficient of that term. So 10x squared times x minus 1 to the 9th. And then plus, so that's u dv, plus, and then now I have v du. So think about what's going to be coefficients in that. When I multiply these together, it's just 2x, x minus 1 to the 10th. And then last time I could combine, but there's no like terms here, so this is simply my final answer. So we're done. Yep, we're done. Alrighty, so let's do this example. I'm going to just go one more time and just do this derivative 2 different ways, because this is a problem where it's equally, like you might prefer either way. So I want to show you both methods, and you can choose if you get a problem like this going forward, which method you want to use. Okay, so I just rewrote the product rule again. So the derivative doing two methods. So I just want to also just again point out that you cannot just take the derivative of the first term and then the derivative of the second factor and just multiply those together. That does not work, okay? It does not work. So my first method is going to be rewrite by distributing. Rewrite by distributing. It's my first method. All right, so go ahead, distribute that out. All right, and we're back. So this is 2x to the 5th plus 5x cubed plus 6x cubed plus 15x, which makes 2x to the 5th plus 11x to the 3rd plus 15x. So this has a ddx in it. That means take the derivative of this. I'm keeping the ddx there because I haven't taken the derivative yet. All right, so since I haven't taken the derivative yet, the ddx still needs to be there. Now I'm in fully rewritten, simplified, standard form. So now I can actually take the derivative. So in my next step, I'm not going to write the ddx because I will have taken the derivative. So go ahead, find the derivative, and then you'll be done. All right, and we're back. So this is 10x to the 4th plus 33x squared plus 15. Woo! All right, so that is our derivative using the rewriting method from distributing. Okay, method 2 would be to actually use the product rule.
We're gonna use this view. So we're gonna actually use the product rule this time. So make your chart for U, du, v, dv. So go ahead and write in what u and v are and what du and dv are. All right, so u is x squared plus 3. U is always the first factor, and v is the second factor. What's the derivative of x squared plus 3? It is, so we're right here, it is 2x. What's the derivative of 2x cubed plus 5x? It is 6. 3 times 2, 6x squared plus 5. All right, so now, using the product rule, you're going to do crisscross and then sum them. U dv plus v du. U dv plus v du. So go ahead, write that out. All right, and here we are. So here we are. This is u dv plus v du. Okay, so now this is a binomial times a binomial, so you're going to multiply that out. You'll get a trinomial, and then this you'll distribute the 2x through. Okay, so go ahead and write that. All right, and we're back. So you get 6x to the 4th plus 23x squared plus 15. So where the 23 comes from is x squared times 5 is 5x squared. And the two inner terms is 18x squared. 5 and 18 make 23x squared. 3 times 5 is 15 plus, and then you distribute this x in, you get 4x to the 4th plus 10x squared. Now let's continue combining like terms. So you have the 6x to the 4th and the 4x to the 4th, which are like terms. So that's 10x to the 4th. Oh, look, like we have before. Interesting. 23x squared and 10x squared are like terms. Those combine to make 33x squared. And then we have this 15. So the fourths combine to make 10x to the 4th. The squareds combine to make 33x squareds. And then you have plus 15. All right. Hope you learned a lot from this video. Next, we're going to do a trig example in class. Oh, boy. All right. Take care. Bye-bye. Ms. Schultz is signing off.